Nearly a decade ago, a billion-dollar agreement was signed that would eventually shake up the global defense industry in ways nobody anticipated. The Thai Navy, seeking to modernize its underwater fleet, entered into negotiations with China for the purchase of advanced submarines. What seemed like a straightforward military procurement deal would soon become entangled in international politics, technological rivalry, and a dramatic test of China's military-industrial capabilities. The story begins in 2017, when Thailand and China finalized arrangements for what appeared to be a mutually beneficial partnership. Bangkok needed capable submarines to protect its maritime interests. Beijing was eager to demonstrate its growing prowess as a credible arms supplier on the world stage. The deal was valued at $1 billion and covered 3 sophisticated underwater vessels that would significantly enhance Thailand's defensive capabilities. But this wasn't just another arms transaction. What unfolded over the following years would become a masterclass in how geopolitical tensions, export restrictions, and technological independence can collide in unexpected ways. The tale involves German engine manufacturers, British certification bodies, Pakistani test programs, and ultimately, a Chinese solution that few experts saw coming. From weakness to naval superpower. To understand why this submarine deal matters, we need to step back and look at China's remarkable transformation over recent decades. Just generations ago, China was considered militarily vulnerable, with limited naval projection capabilities and outdated equipment. The nation's maritime forces were largely confined to coastal defense, incapable of operating effectively in blue water environments. Fast forward to today, and the picture looks dramatically different. By 2025, the People's Liberation Army Navy operates more than 350 vessels across various classifications. This maritime arsenal includes 3 aircraft carriers displacing over 100,000 tons combined, alongside 25 destroyers that represent some of the most advanced surface combatants anywhere on Earth. The pace and scale of this naval expansion is genuinely without precedent in modern military history. Consider the Type 055 destroyer as a prime example of how far Chinese shipbuilding has come. This massive warship displaces approximately 13,000 tons when fully loaded, making it one of the largest and most capable destroyers currently in service worldwide. The vessel bristles with sophisticated weaponry, including a rapid-fire close-in weapon system capable of spewing out thousands of rounds per minute to defend against incoming missiles and aircraft. But the most impressive feature is its vertical launch system. With 112 individual launch cells distributed throughout the ship, the Type 055 can simultaneously engage multiple targets at various ranges and altitudes. This capability allows it to conduct defensive operations against aerial threats while simultaneously launching offensive strikes against enemy surface vessels or land-based targets. When naval analysts in Western countries first observed these destroyers entering service, the reaction was one of genuine surprise mixed with respect. What made this development even more remarkable was the timeline. China went from having a largely obsolete navy to fielding world-class destroyers in roughly 3 decades. This compressed development cycle challenged conventional wisdom about how long it takes to build genuine naval expertise. The business of military exports. Yet military strength isn't measured solely by what a nation deploys for its own defense. Increasingly, the ability to export advanced weapon systems has become a key indicator of technological maturity and industrial capability. China recognized this reality and has systematically worked to establish itself as a major player in the global arms market. The numbers tell a compelling story. According to available data from 2022, Chinese military exports reached approximately $70 billion, capturing roughly 18% of the worldwide market for defense equipment. Just 2 years later, that figure had climbed to around $100 billion, securing China's position as the world's second-largest arms exporter, trailing only the United States. Among the various systems China sells internationally, fighter aircraft have proven particularly successful. The J-10C multi-role fighter jet serves as a prime example. Pakistan began acquiring these aircraft 4 years ago and has already taken delivery of 20 units. The relationship proved so satisfactory that Islamabad subsequently ordered an additional 60 aircraft, with plans to eventually operate approximately 90 of these fighters as a cornerstone of its Air Force modernization program. Another standout export success has been the Rainbow 4 unmanned aerial vehicle. This medium-altitude, long-endurance drone has found an especially receptive market across the Middle East. Many nations in that region face a common challenge. They need effective air surveillance and strike capabilities, but lack the extensive pilot training infrastructure required for traditional manned aircraft. The Rainbow 4 offers an attractive solution, utilizing modern remote control technology that allows countries to quickly establish unmanned aerial capabilities without the lengthy process of developing a large cadre of trained pilots. But as China's catalog of exportable military hardware expanded, attention increasingly turned to more sophisticated systems. Among these, submarines represent perhaps the most complex and sensitive category of military equipment a nation can produce and sell. Thailand's underwater ambitions. In 2015, Thailand made a strategic decision that would have far-reaching consequences. After decades of operating aging submarines or none at all, the Royal Thai Navy determined it needed modern underwater vessels to adequately patrol and protect the nation's extensive maritime territories. An international competition was launched, inviting proposals from established submarine manufacturers around the world. The contest attracted serious contenders. South Korea offered its Changbogo-class diesel-electric submarines, proven designs based on German technology. France proposed its Scorpène-class boats, which had been successfully exported to several navies. Germany itself put forward the Type 214, an advanced air-independent propulsion submarine that represented cutting-edge conventional submarine technology. When China's S-26T submarine emerged victorious from this competitive process, winning the billion-dollar contract, eyebrows were raised throughout the international defense community. Military analysts and submarine experts openly questioned whether Thailand was taking an unnecessary risk by selecting Chinese technology over more established European alternatives. The skepticism was rooted in a widespread perception that Chinese submarines, despite improvements, still lagged behind Western designs in crucial areas like acoustic quieting and reliability. Some commentators suggested that Chinese boats would be easily detected by advanced Western sonar systems, limiting their tactical effectiveness. But Thailand's decision wasn't made in isolation or without careful consideration. That same year provided important context. Pakistan had just concluded negotiations with China for 8 S-20P submarines in a deal worth approximately $5 billion. This represented one of the largest submarine export contracts China had ever secured. The Pakistani agreement included a particularly interesting provision that demonstrated China's willingness to transfer technology, not merely sell finished products. Under the terms, the first 4 submarines would be constructed entirely in Chinese shipyards, allowing Pakistani naval personnel to observe and learn from the construction process. The remaining 4 vessels would then be assembled at Pakistani facilities using Chinese-supplied components and technical assistance. This arrangement would directly enhance Pakistan's domestic submarine construction and maintenance capabilities, building indigenous expertise that would pay dividends for decades. The submarine Thailand selected, designated S-26T, represented an evolution of China's Type 039B design, incorporating specific modifications requested by the Thai Navy. This wasn't simply an off-the-shelf purchase, but rather a customized variant tailored to Thailand's operational requirements and regional operating environment. At the heart of the S-26T's capabilities lies its hybrid air-independent propulsion system. Traditional diesel-electric submarines must regularly surface or raise a snorkel to run their diesel engines, which recharge the batteries that power underwater movement. This necessity makes them vulnerable to detection. Air-independent propulsion technology allows submarines to remain submerged for weeks at a time, dramatically enhancing their stealth and operational flexibility. The vessel's armament is equally impressive. Six 533mm torpedo tubes provide the primary offensive capability, capable of launching up to 18 torpedoes or anti-ship missiles. Alternatively, the boat can be configured to carry 30 naval mines, giving Thailand flexible options for different mission profiles ranging from anti-surface warfare to covert mine-laying operations. The sensor suite includes digital sonar systems capable of simultaneously tracking and engaging multiple targets, a significant advancement over earlier analog systems that struggled with complex tactical scenarios. These capabilities position the S-26T as a genuinely capable platform, not a budget alternative with compromised performance. However, the most critical specification for any submarine is acoustic quieting. Submarines survive and succeed based on their ability to remain undetected. The ocean isn't silent, it's filled with ambient noise from waves, marine life, geological activity, and human maritime traffic. Typical ocean background noise measures between 90 and 100 decibels depending on location and conditions. The S-26T, when operating submerged on its air-independent propulsion system, generates noise in the range of 80 to 90 decibels. This level allows it to effectively disappear into the acoustic background, making detection extremely challenging even for sophisticated sonar systems. To put this in perspective, the United States Navy's Virginia-class nuclear attack submarines, which cost approximately $1.8 billion each, operate within a similar acoustic signature range. Cost considerations played a significant role in Thailand's decision-making process. Modern submarines represent enormous investments, and prices vary dramatically depending on capabilities and the manufacturer's origin. French Scorpion-class submarines, for instance, carried price tags around $565 million per unit. Japanese Soryu-class boats cost approximately $520 million each. German Type 214 submarines exceeded $400 million per vessel. Even Russian submarines, despite being built in a country with lower labor costs, still ran around $300 million each for variants without air-independent propulsion. Against this backdrop, China's S-26T offered remarkable value. At just over $300 million per submarine, including air-independent propulsion technology, it represented the most cost-effective option among comparable platforms. Thailand would get sophisticated capabilities at roughly half the price of European alternatives, freeing up budget for other naval modernization priorities. The financial arrangements also demonstrated flexibility. Rather than requiring payment up front, China agreed to a phased payment structure aligned with construction milestones and delivery schedules. When Thailand subsequently encountered budgetary constraints that prevented ordering all three submarines simultaneously, China adapted the agreement to a ship-by-ship contracting approach. Each vessel would be individually contracted and delivered sequentially, accommodating Thailand's fiscal realities without canceling the program entirely. Beyond the basic platform, China made numerous customizations based on specific Thai requirements. Engineering modifications ensured the submarines would perform well in Thailand's regional operating areas with their particular oceanographic characteristics. The combat management systems were adapted to interface seamlessly with Thailand's existing naval weapons and communications infrastructure, avoiding costly integration challenges that often plague international defense procurements. According to the original timeline, the first submarine should have been delivered in 2023. Yet more than 2 years past that target date, not a single vessel had been transferred to the Royal Thai Navy. The culprit behind this delay wasn't technical problems or construction setbacks. Instead, an entirely different obstacle had emerged thousands of miles away in Germany. Understanding what went wrong requires examining a critical component specification that Thailand insisted upon from the beginning of negotiations. Despite selecting a Chinese submarine design, Thai naval planners explicitly required the installation of German-manufactured MTU-396 diesel engines rather than Chinese alternatives. This requirement wasn't arbitrary. The MTU-396 has earned a sterling reputation in submarine circles worldwide. Designed specifically for underwater applications, these engines deliver high power output while maintaining exceptionally low acoustic signatures, exactly what submarine operators need. The MTU-396 had been integrated into numerous conventional submarine designs across different navies, establishing a proven track record that Thai decision-makers found reassuring. In submarine design, the diesel engines are often described as the heart of the vessel. They generate electrical power to charge the massive battery banks that provide propulsion when submerged and run all onboard systems. The reliability, efficiency, and quietness of these engines directly impacts the submarine's operational effectiveness and crew safety. Thailand's insistence on German engines reflected a desire to combine Chinese cost-effectiveness and construction capability with German engineering excellence in this critical subsystem. Initially, this mixed sourcing approach appeared viable. China had previously integrated MTU engines into other submarine projects and seemed confident it could do so again for the Thai contract. But in 2021, the situation changed dramatically. The European Union had maintained an arms embargo on China since 1989, restricting the sale of military equipment and technology to Beijing. This embargo had been inconsistently applied over the years, with different member states interpreting its scope differently. In 2021, however, Germany chose to strictly enforce these restrictions, specifically refusing to authorize the export of MTU-396 engines to China. As a member of both the European Union and NATO, Germany cited policies against transferring sensitive military technologies to nations outside the Western alliance structure. From Berlin's perspective, allowing these engines to be integrated into Chinese-built submarines would constitute an unacceptable technology transfer, even if the final vessels were destined for Thailand rather than the Chinese Navy. This decision placed the entire submarine program in jeopardy. Without the engines, China couldn't complete construction. Without completed submarines, Thailand's naval modernization plans would stall indefinitely. Recognizing the crisis, Thailand attempted to negotiate a compromise that might satisfy Germany's concerns while keeping the project alive. Thai officials engaged directly with their German counterparts, proposing an alternative arrangement. The German export ban specifically prohibited selling engines directly to China. However, it didn't technically forbid exporting them to Thailand itself. Thai negotiators suggested a workaround. China would construct the submarines minus the propulsion systems and deliver them to Thailand as incomplete vessels. The German engines would then be shipped directly to Thailand and installed at Thai naval facilities, with German or Thai technicians performing the integration work. This approach would maintain the letter of German export restrictions. The engines would never technically be in Chinese possession, while allowing the submarine program to proceed. From Thailand's perspective, it was an elegant solution that respected German concerns while honoring the existing contract with China. Berlin rejected this proposal as well. The refusal revealed that German motivations extended beyond the narrow technical interpretation of export control regulations. The real objective appeared to be disrupting China's growing success in the international arms market more broadly. By preventing the submarine delivery, Germany was signaling to potential Chinese customers that Beijing might struggle to fulfill complex international contracts if they depended on Western components. This uncertainty could encourage nations evaluating competing bids to favor European or American alternatives despite higher costs, seeing them as more reliable suppliers less vulnerable to political complications. From a strategic perspective, Germany also hoped Thailand might abandon the Chinese submarines entirely and pivot to European designs. If Thailand ultimately purchased German Type 214 submarines instead, Berlin would achieve a triple victory, denying China a successful export, capturing the contract for German industry, and weakening Chinese credibility as an arms supplier. The German obstruction placed China in a difficult position. The company had committed to delivering submarines and accepted advance payments under the contract. Failure to deliver would indeed damage China's reputation as a reliable defense partner, potentially undermining future export prospects across Southeast Asia and beyond. Rather than accept defeat, Chinese officials and engineers proposed a bold alternative. Replace the German MTU-396 engines with domestically developed Chinese power plants designated CHD-620. These engines had been designed specifically for submarine applications and featured in China's own naval expansion program. However, the CHD-620 lacked the international recognition and proven track record of the German MTU series. Thai officials understandably hesitated. Switching engines represented a major technical change with potential implications for the submarine's performance, reliability, and resale value. Could Chinese engines really match German quality? Would they prove as quiet and dependable over decades of operation? Many observers expected Thailand to either cancel the Chinese contract or demand substantial price reductions to compensate for what was perceived as a downgrade. The conventional wisdom held that China's submarine export ambitions had hit an insurmountable barrier. But then something unexpected happened in Pakistan that would change the calculus entirely. Pakistan's 8-submarine program had faced the exact same engine supply problem. When Germany refused to provide MTU-396 engines for the S-20P submarines, Islamabad confronted an identical dilemma. Pakistan's response demonstrated remarkable confidence in Chinese capabilities. Without prolonged hesitation, Pakistani naval authorities agreed to accept CHD-620 engines as replacements for the originally specified German units. This decision allowed construction of the first S-20P submarine to proceed without further delays. Over the subsequent 2 years, this boat underwent extensive sea trials and operational testing in real-world conditions. Pakistani crews put the Chinese engines through demanding scenarios, accumulating operational data on their performance, reliability, and acoustic characteristics. Thailand watched Pakistan's experience closely while conducting its own due diligence. Thai naval personnel and civilian technical experts traveled to China on multiple occasions to personally inspect and evaluate the CHD-620 engines at manufacturing facilities and test stands. These weren't cursory visits. The Thai evaluation team subjected sample engines to punishing endurance tests, including continuous operation for more than 200 hours to verify reliability under sustained loads. Acoustic measurements were taken to confirm noise generation remained within acceptable parameters. Fuel consumption was carefully monitored to ensure efficiency met requirements. Beyond China's own testing facilities, Thailand insisted on third-party validation from internationally recognized authorities. The engines underwent certification procedures through Lloyd's Register, the British Classification Society with a centuries-long history of setting maritime safety and quality standards. Successfully obtaining Lloyd's certification provided independent verification that the CHD-620 met international benchmarks for submarine propulsion systems. Thai officials also made site visits to Pakistan to observe the S-20P submarines firsthand and interview Pakistani naval officers about their operational experiences. These discussions provided invaluable real-world feedback from users who had actually operated vessels with the Chinese engines under operational conditions rather than just test scenarios. The technical specifications revealed through this evaluation process showed the CHD-620 to be a genuinely sophisticated power plant. Chinese engineers had incorporated high-pressure common rail fuel injection systems for improved efficiency and smoother operation. Electronic engine management systems provided precise control over combustion parameters, optimizing performance across different operating conditions. Extensive noise reduction technologies were integrated throughout the design, from vibration-dampening engine mounts to acoustic insulation materials. When compared directly against the MTU 396 on key metrics, power output, fuel efficiency, acoustic signature, and reliability, the CHD 620 proved comparable and in some measures superior, particularly regarding fuel economy and reduced emissions. While the German engine remained the gold standard based on decades of operational history, the Chinese alternative had clearly closed the performance gap substantially. 2 weeks ago, after years of uncertainty and exhaustive evaluation, Thailand made its final decision. The Royal Thai Navy officially approved a major contract modification, authorizing the substitution of Chinese CHD 620 engines for the originally specified German MTU 396 units. This wasn't a reluctant acceptance of an inferior alternative. Rather, the decision reflected genuine confidence gained through rigorous testing that the Chinese engines would deliver the required performance. Thailand also recognized the broader strategic implications. By accepting the engine swap, Bangkok was freeing the submarine program from vulnerability to European political decisions beyond Thai control. The modified agreement maintained Thailand's commitment to purchase 2 submarines as an initial batch, with the third vessel remaining an option for future procurement.